Hey guys, so I was doing a training course the other day and we were going through this sort of TDD exercise, and the group asked me if I would record that exercise for them for future reference. So I figured I would just go ahead and record it and share it for everybody. So let's jump into it. Alright, so the basic idea here is just using some test-driven development techniques to kind of explore a little bit of some object-oriented programming. So our first test here is we just got a main program that we just want a circle type, and we're going to make sure we can set its diameter and get its area correctly. And we've got a little script here that's going to do the compile and run the test just to make sure everything's working, right? So to start with, this is all we're starting with, is just this main program and that script. So the first thing we'll do is we'll just start by running that script. Run first test. And of course we get an error here that just this file doesn't even exist yet. So that's the first thing we're going to do, is we're going to create that first circle interface file. First circle interface.f90. Right, and so now we're going to get a different error. Now the implementation file doesn't exist yet. And so the reason we were going to have these two files is we're going to be using the submodules feature of Fortran, where we have the interface in one file and the implementation in another file. First circle implementation.f90. We'll try and run it again, and now we cannot open the module file for the first circle interface.mod. Well, that's because we didn't put a module in the file. So module first circle interface and module, save. Right, and so this is the process you're going to get into if you're trying to kind of do TDD type development, is where you've kind of got a test of this demonstrating what you want the code to be able to do. And so you're going to write the minimal amount of code that fixes the first problem that comes up when you try and compile and run it. So that's why we're getting in this fast feedback loop here. Anyway, so this next error is circle T referenced at 1 not found, right? So we don't have circle T here in this module yet. And before I put anything else in here, we're going to follow best practices and make sure we put implicit none and private at the top of our module. And then now we do need that circle T type. So we say type, we're going to make it public, circle T, and then end type. Alright, so what happens next? Set diameter is not a member of the circle T structure. Right. So when we're going to define, since we're using the submodules approach here, we're going to define the interface to this procedure, but not its implementation. Right. So we need an interface block that we're going to put these in. Yeah. So we're going to say module subroutine set diameter, and it's taking, first of all, it's going to, since we're doing this is object oriented, the circle here gets passed as the first argument, and so by convention usually we call that this, and then diameter is going to be the second argument as specified here with that keyword syntax. And subroutine. Alright, and so now we need to define the types of these. So since we're doing object oriented, this has to be class, and it's going to be a circle T, and it's intent in out, and diameter is going to be a real, and it's going to be intent in. And then we have to follow it with we have to have a contain statement in our type definition, and then we're going to have procedure set diameter. And should take care of that first one. But it says it did not. Let's try that again. Oh, yes. It did. I was looking too high up. So now it's saying area is not a member of the structure. All right. So now we're going to, this one is going to actually be able to be pure. So we're going to say pure module function, because we're calling it like a function here. And it's called area. And its only argument is the circle object and function. And so we've got class circle T, and its intent in, and the result is going to be an area, and it's a real. And so now we can say, and we also need to say procedure area. All right, so let's see what happened next. Oh, now we get all the way to a link error. So it's saying that undefined reference to first circle interface mod area. Right? So what's happening here is we've defined the interfaces, but we don't have an actual implementation yet. So when it goes to, so when the linker goes to actually find the implementation and make sure that the calls are wired up correctly, it can't find the implementation because we haven't provided one yet. So in this one we're going to go over to the implementation file, and so we need a submodule of first circle interface. Get rid of that error there. And it's going to be called first circle implementation and submodule. And we're going to have a contains statement here. And now we can say module procedure set diameter. And now we don't have to repeat the argument list or the argument declarations. And so now we need to decide what set diameter is going to do. Well, at this point we don't actually have to even do that. We're just going to leave it empty for now. And we'll go ahead and try and rerun this. We'll get a different link error. Now it's saying can't find the area, which it was already. So, but anyway, so let's provide an implementation for the area function. All right. Now when we run, we just get that the test failed. So now we can go and look at our test here. So probably what's happening is our area here is not returning anything, and so obviously it's not going to get the right answer. Right? So now we need to figure out how we're going to actually make this test pass. We got everything compiling and running, we just don't get the right answer yet. So now we're going to look at our implementation. So how do I get the right area? Well, I actually at this point could just cheat. So I'm going to take that, copy, paste, and we know that that's 2, right? Because that's what's here. And I'm also going to take the pi parameter, and I'm going to copy that over here too. We're going to go ahead and do that private and do it like that. Private keyword is not allowed or necessary in the submodule. Okay, so there's that part. And there's one thing that I did forget, and this is a gotcha. This implicit none does not apply inside the interface block. So we got to make sure and put that at the top of each of our interfaces to make sure that the implicit none is in effect there. Okay, so now we've we really cheated here, but I bet our test is going to pass. It does. Right, so we get test passed. Now, we're cheated here. We didn't actually implement the desired functionality here. What we really want to do is, this is supposed to set a diameter of the circle, and then this is supposed to compute the area based on that diameter. So let's actually implement that. So we're going to add an extra private keyword here to follow best practices in terms of information hiding. And it's going to be a real, and we're going to call it diameter. And now we can go over to our implementations here, and what's supposed to happen is we're supposed to say this percent diameter equals diameter, right? So this is the argument as defined by the interface here, and then this has a component diameter, so that's what we're doing. We're taking the component and setting it equal to our argument there. And then area, now instead of hard coding that 2, we're going to use this percent diameter in place. And now this will pass as well. And now for bonus points in the exercise, I said instead of having a diameter as the component, let's try and make this radius and use it the same way. So the way I implemented this is, now we have a radius component, so we're going to say that radius is diameter divided by 2. And now in here, we're going to take the radius squared, if I spell radius correctly, and then we don't actually need to divide by 4. Right? And so now things can look a little bit nicer, and our test will still pass. So cool. So that's the first part of the exercise. So now we have the next step. So in our next step here, we have very similar test. And so we're going to close these and that. And we'll close our script and take a look at our next test. So it's very similar, but after we've set the diameter, we're going to print the area of the circle before we actually do our test here. But what's interesting now is in our print area function, we're doing an assertion here that our circle has actually been defined. And so this is a pattern that comes up occasionally, where we want to make sure that our value here that we're getting in has actually been assigned some sort of a value. So the intended behavior here is that we'll have some component that has default initialization to false, and then anytime we set the value, we'll set that to true, so that we know that this value has been set up properly. So we'll start off with our run test script here, and we get object interface no such file. So what we need to do is we need to define our object interface here. Actually, I think, I swapped these. Hold on. Somehow I swapped the run third test and run second test. So we're not to this point yet. We shouldn't need that file yet. So I'm going to move run third test to run second test dot temp. Move run second test to run third test dot sh. Move run second test to run second test. There we go. So now we'll close that one. So now our run second test here should be the right one. Yeah. Now our script here should be correct. So let's run that. Okay. Second circle interface. So in this instance, I'm just going to copy paste our first implementations, and we'll start from those. So copy first circle interface .f90 to second circle interface .f90, and copy first circle implementation to second circle implementation. This way I can save these intermediate steps and you can run them independently. Alright, so now that we've got those copied over, let's run our second test. And it says, cannot open module file. Oh, because we copied and pasted those, but we didn't change the names. So that's what we need to be doing here. Oop, that's the .o file. So we need second circle interface here, and we need to change the name to second. And same thing with the implementation file. Second circle interface, second circle implementation. Now that should work. Okay, cool. But user defined is not a member of this circle T structure, right? So it's trying to call this function, which we haven't defined in our interface yet. So let's see that. So we're going to need a procedure that is user defined, and that is a pure function, user defined. It's got one argument, the circle, and function, and so it's class circle T, intent in this, and the result is a logical user defined. Okay, so now when we run this, now we get the link time error of user defined doesn't have an implementation, so we need to go and implement that in here. Procedure user defined and procedure. Now we can cheat again here because there's not anything that actually is testing that this works. We can just say that user defined equals true. And our test is actually going to pass now. But we did cheat a little bit. The intended behavior really here is that we have a component here that is a logical component, and we'll just call it defined. And it is default initialized to false, so that when this gets declared here, at the beginning of the execution of the executable statements, that component has a value of false. But when we set the diameter, we're going to change that value to true, so that by the time we call print area, this is returning that value and it's going to be true, and we can print the area. So that's the intended behavior here. So let's go ahead and implement the actual intended behavior. And we're kind of taking a step a little bit ahead here, but rather than inside of the set diameter routine accessing this component directly, we're going to also have an additional procedure that says mark as defined. And it's going to be a subroutine mark as defined, and it will only have the one argument, which will be class circle T intent in out this. All right. And so now we need an implementation for that as well when we go and implement the actually desired behavior here. So module procedure mark as defined, and procedure, and we're going to say this %defined equals true. So that's the intended behavior of this procedure. And now user defined is supposed to return this defined, and in our set diameter routine we say call this %mark as defined. That's the idea here. And so now our test still passes. Alright, so now we're done with this implementation. And now in the third test, what we're going to do, the third test is actually, and we'll go close these other ones out for right now. The the third test is actually exactly the same as the second test, but we're compiling it. Our compiling script here is a little bit different. We want an object interface and implementation. So the idea here is we're going to create a base type that our circle is going to inherit from to implement this functionality, rather than implementing it directly on the circle type. And so for this one, we're actually going to copy and paste the first implementation and interface for the circle, and then we're going to need to implement these object interface and implementations, and then we'll just add just one keyword, or one little keyword and argument that will actually do this for us without having to modify anything else in the implementations. All right, so I'm going to copy first circle implementation.f90 to third circle implementation.f90 and first circle interface.f90 to third circle interface.f90. And so let's try and run our test here, and we get the object interface, no file or directory. All right, so we need to create a new file, object interface.f90, and then we can try it again, and now we see, oh yeah, we need to create the object implementation.f90, object implementation.f90, and we'll run it again and use third circle. Oh right, we didn't change the third circle interface and implementation files to have the right name. Third circle interface and third circle interface, third circle implementation. So that's what we want. Alright, so now we get that user defined is not a member of the circle T structure, which is what we expect, right? Because we haven't actually changed the interface and we haven't added that here. But what we're actually going to do is, instead of adding that functionality to the circle T type, what we want to do is we want to say extends object T. So now what this is going to do is it's going to say object T has not been previously defined. But what we want to do is we want to say use object interface only object T. Now we get that module hasn't been defined, which is true. Module object interface and module. And we'll go ahead and use best practices and put implicit none and private there. And next, when we compile, it's going to tell us that should tell us that the object is not found in that module, which it's not. So now we're going to say type public object T and type, and it's going to tell us that user defined is not a member of the object T structure. So now we're getting a new, so it's not telling us that it's not a member of the object structure, or of the circle structure. It's telling us it's not a member of the object structure. So now we have to say user defined in an interface block. Interface, there we go. And this needs to be a pure module function, user defined. It's only going to take one argument. And we'll remember to say implicit none in here. And class. Now this time it's class object, intent in, this, and logical user defined. Okay. Oh, but we need in a contain statement in the object here, procedure user defined. So now we should get all the way to the link stage. We do. So we just don't have an implementation for user defined, which we go over here to the object implementation, submodule, object interface, object implementation, and submodule. And it's going to contains module procedure user defined and procedure. And at this point we can go ahead and cheat, and this will pass our test. We can just say user defined equals true, and now our test is going to pass, right? But we didn't actually implement the intended behavior yet. The intended behavior is that we have that mark as defined procedure here as well, and our implementation here calls that. So we want to be able to say call this %mark as defined, which means we need that here as well. So our intended behavior here is that we have logical defined equals false, and then we have a procedure here that is mark as defined, and that's going to be a module subroutine mark as defined. It only takes one argument. And it's implicit none, and class object T, intent in out, this. And then we need to go and provide the implementation, module procedure, mark as defined, and procedure, and we want this %defined equals true, and this to be this %defined. Now we should still pass our tests. There we go. Now what we've done here is we've implemented some basic behavior that we want to be able to add to our circle type here. And in order to add that, all we had to do was we had to just say this extends keyword, and then we can make use of that functionality here when we say we want to mark this object as defined. Notice that we didn't actually define this procedure on the circle type. We defined it on the object type, and it came along when we used this. We got that behavior when we extended that object type. And then we can use the user-defined function from the object type, even though we're calling it on a circle type. So that extends keyword that brings along all of the functionality, all of the components and procedures from the type that it's extending from. So that was the basic exercise, and we've run all the way through it. So I will make this available publicly so you can check it out and try and run and go through these on your own. And hopefully you find this a useful exercise.